So let's move to example 11. In fact, I'm going to solve all the problems on instantaneous center of zero velocity, because in fact, for each problem, we have a certain special case. So I'm not going to skip any problem in this topic, all right, so that you can practice. Now, here I have in example 18, the crankshaft AB rotates at omega AB is equal to 50 radians per second. All right, so from the first impression, I can say that A is what? A is fixed, which means A is IC for AB, but it is for any instant. So for any instant, VA is equal to 0. And from the first line also, I can say that VB should be perpendicular to VB should be perpendicular to what, guys? So AB, perfect, because A is fixed. So VB is vertical. So this is from the first sentence, all right? So since this crankshaft AB rotates about A, and since A is fixed, then VB is perpendicular to AB, and A has a zero velocity. And don't forget, guys, that I can find VB directly since I know omega. So what will be VB? VB will be equal to 50 times 0.1, which means it's 5. So from the first sentence, I know the direction as well as the magnitude of V. So it's 5 meters per second, all right? And it's vertical. Now, from the second sentence, and the disk is at C is held fixed. So I know, guys, that this disk is fixed, which means C is fixed, which means VC is equal to 0. And this means that C is the center of rotation of CD. And what does this mean? What about the velocity at F? What is the direction of the velocity at F? What is the direction of the velocity at F, guys? It should be along BF. Since this, guys, this should be perpendicular to CF, and BF is perpendicular to CF, then this will be VF. And why am I taking this VF upward? Because in fact, omega is clockwise, which means it will hold B upward. And since B is held upward, guys, then VF should be also held upward. And that's why I took VF upward, all right? So VF should be perpendicular to CF. Now, I know the direction of VF, but I don't know the magnitude of VF. I don't know the magnitude of VF, but I know the magnitude and the direction of VP. Now, from these two facts, from VB and VF, I can what? I can find the instantaneous center of zero velocity for what beam, guys? Perfect, Noor, for beam BF, because B and F belongs to this beam. I know the directions of their velocities, so I can find IC for BF. So let's find IC for BF. I'm saying that VF is along BF. This is VF. And VB is vertical because it's perpendicular to AB, so this is VB. Then I can draw the perpendicular lines to VF, which is CD. As well as the perpendicular lines to VB, which is the horizontal line. Now their intersection will be what? Will be IC, but of what, guys? IC of BF. Now here, Batul, and Noor, I don't have the same IC for the whole crankshaft, and I don't have the same omega for the whole body, because in fact they are connected links, so they can rotate with different angular velocity. All right, so they are not a same body or a same disk or a same square plate or a same plate that is rotating with the same angular velocity as the previous example. Okay, so guys, this is my IC. Now, if I know VB, in fact, right? It's 5 meters per second. And if I can find BIC, then I can find omega of BF. Why? Because omega of BF is equal to what? Is equal to VB over BIC. VB is 5. What about BIC? What about BIC? In fact, guys, if you take a look on this triangle, this is what? This is what? What is the type of this triangle? This is a semi-equilateral triangle, because in fact, this is a 60 degrees, this is a 90 degrees, then this will be 30 degrees. And this means that if this BF is 300 millimeters, then BIC will be 2 times the 300, which is 600 millimeters. And then FIC will be radical 3 times 300 millimeters, or radical 3 over 2 times 600, it's the same millimeters. All right? All right, guys, and this will be 0.5152. Okay, so this is from geometry of semi-equilateral triangle. All right, so guys, VB will be equal to 5 over BIC, which is 600 or 0.6 meters. And this means that omega BF will be equal to 8.33 radians per second. Now that I know omega BF, it's very easy to find VF. What is VF? VF will be equal to omega BF times the distance between F and IC. So it's omega BF times this distance between F and IC, which is 0.52. And this means that VF will be equal to 4.33 meters per second. Am I done? In fact, no, because the question is to find the angular velocity of CD. But I know VF, and I know that CD has a center of rotation, which is C, since C is fixed. And this means, guys, that VF for the beam CD is equal to omega CD. So VF, on the other hand, VF is equal to omega CD times the distance between C and F, since C has a zero velocity. And this means that omega CD, which is the question, is equal to 4.33 over 0.7075. And this means that omega CD is equal to 57.7 radians per second. All right, guys? All right? Yes, but well, C belongs to the disk, and the disk is fixed. Right? So C cannot move because the disk is fixed. All right? So this is the question. They are saying that the disk is held fixed. Right? And I need to determine the angular velocity of CD that I have determined here. And don't forget that the unit of omega CD is radians per second. Any question?